There's a pretty good chance that you've explored triangular numbers in your life, probably because you've done something like this. You get a bag of Skittles and you open it up and you just dump them all over the place. You can also use M&Ms, but once you've had good chocolate, you realize M&Ms are kind of an inferior candy, but Skittles are great, especially if you're out hiking. What you want to do is, if you're going up a mountain and you're feeling kind of tired, is just eat a couple big handfuls of Skittles. You get instant blood sugar and you can keep on going, which probably means it's a terrible choice if you're just sitting around recording math videos, but here we are. So to make triangular numbers, you've probably done something like this, where first you take one candy like this, and then you take two candies and you put them like this, and then another one on top to make three, and then you go ahead and just continue the pattern. And now you just count up how many candies are in each pile. Here's 1, here's 3, here's 6, here's 10, here's 15, and how many would be in the next pile? Well, it's not a completely complicated pattern, because each time you need to add one more than the previous row. So here's 1, you add 2, then you add 3, then you add 4, and then you add 5. So if you went ahead and added another layer to this, you'd get 6, 21 candies. Let's go ahead and put it up to check. And no matter which way you count them up, you get that there are indeed 21 candies. So you can make triangular numbers by adding up integers. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. All of those are going to be triangular numbers. So there's a formula for triangular numbers. The triangular numbers are given by the formula n times n plus 1 over 2. So what does this mean? Well, you pick any value of n, suppose like n equals 6. So you put it in the formula 6 times 5 over 2 equals 30 over 2, which is going to be 15, and 15 is indeed one of our triangular numbers. So any value of n you put in this formula, you just do the math and you're going to get out a triangular number. Triangular numbers and square numbers are incompatible. You might think that they might go together, but look at this. We make a triangle, and this time let's stack it up like this instead of going in the gaps. And then you make another one. You can try to put these together, but they don't make a square, they make a rectangle. Okay, well you think, okay, well maybe if I do a bigger one, it'll work out. But it still doesn't work out, because if you push these two together, then you're going to get some overlap on the diagonal. Well, what if you use two different triangular numbers? Well, you can do that, and that works out pretty well. So two separate triangular numbers can make a square number, but two of the same triangular numbers will never make a square number. In fact, any two triangular numbers, if they are sequential, can make a square number. So here we have a triangular number with a base of 5, and here we have one with a base of 4, and we shove them together. We do indeed get, after a little manipulation here, a 5 by 5. Well, you can explore mathematically why that is, but you can just check that it works. If we do 1 plus 3, we get 4, that's a square number. If we do 3 plus 6, we get 9, that's a square number. 6 plus 10 is 16, that's a square number. But going back to this formula here, if we do n times n plus 1 over 2, and then we do one that is smaller than that, so instead of n, we're going to use n minus 1. We just subtract 1 from that n, subtract 1 from this n. So n minus 1 plus 1 would be n over 2. Then we can add these two together. We get n plus 1 plus we get n squared. And n squared is clearly a square number, because any value you put in here for n is going to end up a perfect square.